Okay, so as we continue to factor trinomials, we can always use the methods that we've used before now, depending on if it meets those requirements, right? A is 1, or in this previous case, the AC method when A wasn't 1. But what we're going to do now is we are going to look at this in a sense of special cases. So as you can see here, some of the special cases might be factoring a perfect trinomial square, which is these up here are examples of perfect trinomial squares, where you have a squared plus 2ab plus b squared, or it would be a plus b squared. Mathematically, something like x plus 1 squared is a perfect trinomial square. And what you find out is when you multiply that out, there's going to be patterns that are going to form, and that's what we're doing here. We're looking at this pattern. So what do we see here by looking at our formula? I can see in my formula that I have a square, and then here I have 2 times what would be the a and b values. Or here in this other example, I have negative 2 times what would be those examples. And the only difference here is if I showed you that this example is a plus b squared, this example over here would be x minus 1 squared. Those would be examples of perfect trinomial squares in the factored form. So coming over here, if you notice, what is the factored form of 64x squared minus 16x plus 1? Well, I can tell you that that is a perfect trinomial square, but why? Well, if we notice, 68 is a perfect square, 1 is a perfect square. I said 68. 64x squared is a perfect square, and 1 is a perfect square. And if I find the square root of those, and I know that this is 8 times 8, and this is 1 times 1, so in my formulas, this would be a, that would be b. I know that I have a negative 16x, which is the same thing that we have over here, which is negative 2ab. So I can do the other methods, or I can look at it and say, well, I know that that is going to be I have a minus b. I have a minus b, or I have a minus b squared, and I'm able to factor that. And if we were to go back and, just check this, right? If we used our FOIL method, we would have x squared times x squared times negative 1. We would have negative 1 times 8x squared, and then negative 1 times negative 1. And that would give us, and if we went back and multiplied it out, yep, here we go. We have 64x squared minus 8x plus 1, or 64x squared minus 16x plus 1. So yeah, checking our work, that turns out that that is the factored form right here. So looking at this next example, special cases, factoring the difference of squares. This one is hugely useful for us, and it makes things so quick, so easy. But when we look at our problem, it says, what is the factored form of 16x squared minus 81? And what you'll notice here is we end up having, in this formula that we have over here, we end up having an a squared minus a b squared. So that is a difference of squares, the square of a minus the square of b. And here, if we look at 16x squared as a, and minus, there's our difference of 81, which is also a squared. So we can split that up very simply. The square root of 16x squared is 4x. And then I know that the difference of squares comes with a addition and subtraction, right? And that's because that'll zero out some stuff later on. And then, of course, my b, the square root of 81 is going to be 9. And that is the factored form of the difference of squares of 16x squared minus 81. And let's check it real quick. And when we multiply it back out, you'll notice we do get our 16x squared, but we get this plus 36x minus 36x, which turns out to equal 0. And then we get minus 81, and